Currently you're adjusting the span, the range nut, in the Foxboro Model 13A differential pressure transmitter. You have an applied pressure here of, where is that?
34.
34, oh right, 34 inches. Difficult to see against the clamp on the tube. And 34 inches of water column going to the high side of the differential pressure transmitter. You're shooting for 15 psi on the output. You're adjusting that range nut to get there. So by adjusting the range nut, you're changing the leverage between the feedback bellows and the sensing capsule, the diaphragm of the transmitter. And of course, every time you touch that nut, it makes the pressure bounce around because you're applying force to it. So you have to sit back, let it stabilize, and see where it settles. You're going for a range of 0 to 34, is that correct?
Correct.
Okay. Look at the other side here. We're using a pressure module here in the Fluke 744 that has an upper range limit of 15 psi. So as a consequence of this, every time the output pressure of this DP cell goes significantly above 15, this shows exclamation marks. It goes over range, like it's about to do right now, as Shane puts his wrench on it. And of course it doesn't because I'm videoing it. Right, okay. So 15.05, getting awfully close to the upper range value. This is, of course, as we continue to hold 34 inches water column on the manometer. Very close here, 15.034. We're trying to achieve at least plus or minus 1% of span. Span being 12 psi in the pneumatic output range, so 1% of that is 0.12 plus or minus, so well within the 0.12 at this point. However, these transmitters are capable of much greater precision. It's not unheard of or impractical to shoot for plus or minus 1/4% of accuracy for a transmitter in good condition. And of course you can hear the hissing in the relay, the air that's bleeding past, and also the air that's bleeding out of the flapper nozzle assembly right there.
Fine tuning.
Yeah. Sometimes when you turn that range wheel, you'll catch a burr on the edge of the range wheel, and that will change the leverage in ways that you don't expect. So here you're settling in at 15 psi. This is a tedious procedure. 14.995, 994.
We got about that.
Then of course when you adjust the range wheel, it's going to interfere with the zero adjustment. So pretty soon Shane's going to take the pressure off of the DP cell and check and see where it reads at 0 inches of water column applied. I'd say stop there. Let's check on 0, because you know you're going to have to adjust to 0 anyway. We're shutting off the air supply here. Air supply for our test pressure regulator. And because it has a 3-valve manifold on it, it makes it very convenient. You can open up the equalizing valve and close the block valve, and that will
shut on.
That will bleed off the pressure applied to its transmitter. You can audibly tell that there's a pressure change. This isn't hissing quite as much as it was before. It's not having to counterbalance as much force. And you can see here we are sitting at 2.2 psi, or supposed to be at 3. So we're doing the coarse adjustments. My recommendation is that you don't try to nail it exactly on each end. It's just going to mess it up. Get it approximately at 15 at the high end, approximately at 3 at the bottom end, go back and forth. Then towards the end steps, take lots of time to get it dialed in. So Shane is adjusting the 0 screw at this point. And the 0 screw is adding or subtracting tension through a spring to the bottom of the range bar. You can see the stainless steel colored spring right there. He turns that screw, pulling a nut on the spring, which is going to pull it in that direction, pulling back on the range bar, causing the balance system to have to apply more pressure inside the feedback bellows. And that causes the output pressure to rise. So he's shooting for 3. Actually, Shane, I'd stop right there, because when you go back to your high pressure, it's going to be messed up. Exactly. So now he's going to move his manifold to apply pressure to the high side again, 34 inches of water column. Closing the equalizing valve and opening the block valve and adjusting his regulator.
No overshoot.
No overshoot. Yes, yes. And turning on the supply. Since we are using a water manometer, he's being careful to avoid applying too much pressure to it, possibly forcing the water column to go up too rapidly. There's the water column right there. As he adjusts the pressure up, I'll try to follow it with the camera.
Usually a big spike when I get to the regulator point.
Right, right. You're at the bottom end of the regulator's range where it doesn't really do anything.
Yeah.
It's continuing to turn the knob clockwise. There we go. Now it's rising up. And we're going to shoot for 34 inches of water column. Reading the bottom of the meniscus on the water column, the part where the fluid surface level is curved. Imagine drawing a center line down the middle of the tube and reading the meniscus at the point where the center line intersects the meniscus. So at this point, he's adjusted that. He should get 15 psi. He's getting a little bit more out of it because of his zero adjustment moments ago. So now he's compensating by turning the range wheel. And back and forth we go. Zero span, zero span, zero span. We do it again and again until we get the transmitter dialed in. Then we check it at more than just 2 points to ensure we have good linearity. And that is the joy of calibrating pneumatic instruments.